Hello, my name is Dominik Subotic and I'm a Master of Science in Environmental Engineering. Welcome to the tutorial for CAIROforAERMOD. We will learn how to compile and run AERMAP, AERMOD and AERPLOT inputs. When we first open CAIRO, we find the AERMAP, AERMOD and AERPLOT input file compilers on the left and the option to run the aforementioned stages on the right. The first step is to open the AERMAP input compiler to create the receptor grid. The user can scroll through the text boxes using the Tab button. First, we must enter a title that must be repeated throughout all the AERMOD stages. The user has the ability to choose national elevation data or digital elevation model format. We will choose NED because our elevation is in TIFF format. This is hinted to the user by tooltips that pop up while hovering over buttons. By clicking the Orographic Files button, we can choose elevation data used for our analysis. Multiple files can be chosen and will be listed in the interface. Next, we must input the UTM coordinates and zone of the anchor point, which is the bottom left corner of our receptor grid. This can be done manually or by clicking the Open Map button, which opens Google Maps. In Google Maps, we can select our anchor point by right-clicking on the wanted coordinate and copying them by left-clicking the latitude-longitude pair. This can be also done simply by copying latitude-longitude pairs from a text file. The coordinates are automatically converted to UTM northing, easting, and zone and input into the interface. For demonstration purposes, we create a coarse 2.5 by 2.5 kilometer grid consisting of 50 receptors spaced by 500 meters both in X and Y direction. By clicking Compile, the program prompts us to select a folder where the input file will be stored. We will create our main project folder where the files necessary to run all the AERMOD stages will be contained. We create a folder, enter it, and click OK. In the folder, we can see the compile AERMAP input file and the elevation data necessary to run AERMAP that was automatically copied into the folder by the program. Now we have set up the required input files to run AERMAP simply by clicking it in the CAIRO interface. After AERMAP had ran, we can see its output, including a file called recept, which contains the receptor grid. Here we can see a scheme of the grid we have created. Now we can open the AERMOD input compiler. There we need to input the same title as before. We have the option to input 3 or less averaging periods. Next, we enter the pollutant and receptor height. To add a point source, we click the Add Point Source button, where we can input coordinates either manually or again by copying coordinates from Google Maps or a text file. Next, you click Open Map, which opens Google Maps in your web browser, allowing you to copy a coordinate, which is then automatically converted to UTM and inserted into the interface. As sources are input, Google Earth automatically opens where our sources are visualized on a map. This can be useful also for finding the base elevation, which is available on Google Earth. After that, we can input the rest over the source data. Next, we will input some additional sources for demonstrational purposes. When the input data gets too large for the window, the user can scroll up and down using the mouse wheel or left and right using the mouse wheel and control button in combination. To add a polygon source, we click Add Polygon Area Source with Google Maps. There again, we are prompted to open Google Maps to input the vertices of our polygon. In the same fashion as before, we copy coordinates to input them into the interface. The program will add a vertex to the polygon with every action of copying until a new polygon is added. Source data can be input afterwards. We will add another polygon, which will be shown on Google Earth. Next, we input the group name that should be the same as the title. We choose the receptor file, which is located in our project folder, and our surface and upper air meteorological files, which will then be automatically copied into the project folder by the program. Then we can input the rest of the data, like station number, start and end of the analysis, and output options. The available outputs are rankfile, maxifile, and plotfile. For the whole period, averaging period, rankfile and maxifile aren't available, so the program will omit them. By clicking compile, the program prompts us to select the project folder and compiles the AERMOD input files and copies other accessory files. Here we can see the AERMOD input file we have created. Notice that for the whole period, the rankfile and maxifile have been omitted, and a different keyword is used for the plot file. Now we can run AERMOD by clicking the AERMOD button and choosing our project folder. After AERMOD has ran, we can look at its output. Now we can compile our AERPLOT input file. The version number should be input as 2 by default. The UTM zone can be entered either manually or by copying the coordinates from Google Maps. We need to input the same averaging periods and group name as before. Maximum and minimum bins can be set by the user, but we will use the data range for now using the keyword data. Next, the user can choose either linear or logarithmic binning methods from the drop-down menu and input other plotting options or totally disable them. By clicking compile, we are again prompted to select our project folder. By selecting, the program will create a subfolder for each averaging period, where all the necessary files to run AERPLOT will be automatically copied into. Next, we can run AERPLOT and select our project folder that contains the 3 subfolders. The program will automatically convert all 3 averaging periods to KML format at once. Finally, we can see our plotted concentration distribution. Thank you for your attention and feel free to contact me for any inquiries.